Hi, this is Christina Amendeo's presentation on the cardiovascular project. I can't find a screen recorder that will allow me to record. I've already reached my limit on all of the free ones, unfortunately. And I did see it in the directions that the classroom presentation just needed to be 5 minutes, so I am going to skip over a good portion of some of the slides, like just kind of go over the slides like I would if I was in a classroom and had a 5-minute time limit. So I'm just going to show the slideshow on my laptop with my phone. So this is the cardiovascular system. This is my goals for the presentation. So it just matches the goals for the cardiovascular project on Canvas. So I drew a couple pictures of the heart and colored them in and labeled them. So this is the anterior view of the heart, and it shows the major structures, the ones that are important to know. The posterior view of the heart, this is another one that I drew and labeled as well. And then the list is the frontal view of the heart, and it also depicts the blood flow through the heart. So it shows the blood coming in through the superior and inferior vena cava, and kind of going down through the right atrium and then up through the pulmonary trunk, where it goes out to be oxygenated by the blood. Oxygenated by the lungs. And then it comes in through the pulmonary veins. It goes down through the left atrium into the left ventricle, where it goes up into the aortic to the aorta, and then out through the left common carotid artery, the left subclavian artery, and the brachiocephalic trunk. And then it also comes out through the descending aorta. So that kind of gives you a depiction of the blood flow and how it moves through the heart. So this slide is about the systemic and pulmonary circuits. So this over here just gives you a picture. I thought it was a really good picture, and it showed the different vessels and what kind of blood they were transporting. So the red is oxygenated, this is deoxygenated, the blue, and then it says systemic arteries carry oxygenated blood to the body's tissues. The blood returned to the heart via the systemic veins is less oxygenated because much of the oxygen carried by the arteries has been delivered to the cells already. The pulmonary circuit arteries carry deoxygenated blood to the lungs to become oxygenated. The pulmonary veins then return the oxygenated blood from the lungs to the heart, where it is then pumped out back into the systemic circulation. This slide is on the arteries and the veins. So it goes over the structure of arteries versus veins. So it goes over how arteries have thick walls with smaller lumens, as depicted here. So this is the lumen here. This is the vein, and then here's the venous lumen here. The arteries have thicker walls due to how much pressure is in them. It goes over how larger arteries and veins contain vasa vasorum, and then it goes over how both arteries and veins have the same distinct tissue layers, but how they vary in structure, and that's why I included this picture over here as well. I think it shows the difference between an artery versus a vein. Although they have the same 3 tissue layers, they look a lot different, and they even look different depending on what kind of artery or vein it is. This slide here goes over other types of blood vessels. So it talks about how arterioles are extremely small arteries that lead to a capillary, how they still have the same 3 tunic layers, but the tunics are smaller. The tunica externa is very thin in an arteriole, and then it goes over their functions as well. It goes over how capillaries are microscopic channels that supply blood to the tissues. It goes over how their walls have to be leaky to allow substances to pass through, and it goes over the different types, which are continuous, fenestrated, and sinusoid capillaries. It goes over the structure of the wall, how it is an endothelial layer surrounded by a basement membrane with the occasional smooth muscle fiber, and then how the wall structure depends on how large the capillary is. It talks about how venules are very small veins, how the walls consist of endothelium, which is a thin middle layer with few muscle cells and elastic fibers. I mean that the walls consist of endothelium, also a thin middle layer with a few muscle cells and elastic fibers, along with an outer layer of connective tissue fibers that create a very thin tunica externa. Both venules and capillaries are the main site of emigration, where white blood cells adhere to the endothelial lining of the vessels and squeeze through adjacent cells to enter the tissue fluid. So this here goes over all the different arteries in the body. So these are the different arteries throughout the brain. And then here is the veins in the head and neck. And then over here is the arteries throughout the body. So you basically can just trace a drop of blood through this. So if you were looking at this is the aorta here, and then the blood would be sent out over this way and then down through the arm to get to the hand, for example, or it would come down through the descending aorta, and then it could be distributed to either leg, and that just depicts those different arteries, and you can see how the blood would flow throughout them. This is the venous blood flow, and then this is the veins of the head and neck, and then this is the veins of the body. Same thing, you can imagine how the blood would be sent back to the heart to be distributed to the lungs, to be oxygenated again, and then sent out through the arteries. So you can take a look at that. This slide here goes over the different blood cells. I absolutely love this chart right here. I thought it was such a great chart from the textbook, and it was really helpful because it has every different kind of blood cell that we talk about in the chapter on this, and it goes over their functions, their appearance, how many are in the body. So I thought that was really helpful, so I did include that. And then I put a brief definition of each one on the other side of the slide. So it talks about how erythrocytes are red blood cells. They're the most common formed element. The shape facilitates gas exchange, so that's why they look the way they do, and it allows them to fold up as they move through blood vessels. Disorders of the red blood cells, such as sickle cell disease, can potentially be an issue because they can cause a blockage. Leukocytes, white blood cells, are crucial to the body's defenses. It goes over the 3 different granular leukocytes, and why they're called that is because the granules in their cytoplasm. Then the agranular leukocytes have less granules, but they still do have them. Platelets are fragments of the cytoplasm of a cell that is surrounded by a plasma membrane. And then it goes over their important function. And then this slide here, I thought it would be helpful to do a review. So if we were doing this in class, we could ask the questions to the class and get some answers. So the first question is, do arteries carry blood to or from the heart? So obviously arteries carry blood away from the heart, and that comes up here. Then it also just says how veins carry blood to the heart. How does blood flow through the heart? So I thought this was really helpful to include besides just the picture depicting that. So it talks about how blood enters the right atrium from the superior and inferior vena cava. The blood in the right atrium flows through the right atrioventricular valve into the right ventricle. The contraction of the right ventricle forces the pulmonary valve open. The blood then flows through the pulmonary valve into the pulmonary trunk. Blood is distributed by the right and left pulmonary arteries to the lungs, where it unloads carbon dioxide and loads oxygen. The blood then returns from the lungs through the pulmonary veins to the left atrium. The blood in the left atrium flows through the left atrioventricular valve into the left ventricle. The left ventricle contracts and forces the aortic valve open. The blood then flows through the aortic valve into the ascending aorta. Blood in the aorta is distributed to every organ in the body, where it unloads oxygen and then loads up on carbon dioxide. The blood then returns to the heart through the vena cava, and the process repeats all over again. Then the next question, how is deoxygenated blood oxygenated in an embryo? So the blood is oxygenated through the placenta in an embryo. And this here is my reference, which was the textbook for my slideshow. And that precedes the end of my first part of my project presentation. And then I will upload this along with my case study and the script for this presentation. Thank you very much.